So this is Unit 4B. It's really just a continuation of Unit 4. You still need to know all of the things that we learned about quadratic graphs for this unit as well. So we're going to start by reviewing that. So remember, vertex form looks like y equals a, and then parentheses x minus h squared plus k, where h and k are actually your vertex. So it's called vertex form because just by looking at it, you know what the vertex is. And remember that h value, x is always lie, so it's always the opposite sign when it's next to the x. So for instance, if you have negative x plus 1 squared minus 4, your vertex is really negative 1, 4. So you have to plot the vertex. So you're going to plot negative 1, positive 4. And then you're going to look at your a value. And so remember, the a value is the thing that's in front of the parentheses. So in this case, it's negative 1. And if the a value is a positive number, or just as simply a 1, you're going to use the pattern of 1, 1, 2, 4, 3, 6 to plot other points. But if the a value is negative, like in this case, then you're going to use the same pattern, except the parabola will go down instead of up. And if the a value is anything except 1 or negative 1, you're going to multiply that a value by the second part of the pattern. So, for instance, if your a value is 2, you would go over 1 up 2, over 2 up 8, and so on and so forth. And then you connect the points with a smooth U curve. So let's go ahead and do that. Let's plot the vertex. The vertex we said was negative 1, positive 4. So you put a dot there. And then your a value is negative 1. So you're going to go over 1, down 1. You're going to go over 2, down 4. Or over 3, down 9. And then you're just going to reflect those points on the other side. So I'm going to go in the other direction, over 1, down 1, and so on and so forth. And I'm going to connect these with a nice smooth curve. So that's how you graph when you are in vertex form. If you are in standard form, you're going to transform this equation into vertex form in order to be able to graph it. So if we want to graph y equals 2x squared minus 8x plus 5, that is in standard form. The first thing you're going to do is, before that, remember that the last number is always your y-intercept. That c value is your y-intercept. So you know that your y-intercept is 5, or as an ordered pair, 0, 5. All right, so in graphing in standard form, you're first going to identify the a, b, and c values. Then you're going to use the equation h is minus b over 2a to find the x value of the vertex. You're then going to plug that value into the equation to solve for y, also known as your k value. It's the y value of your vertex. And then once you have it in vertex form, you're going to graph it like we did in the previous slide. So let's go ahead and do that. My a, b, and c values are 2, negative 8, and 5. I'm going to do minus b over 2a, so it's going to be a minus 8 over 2 times a, which is 2. So that'll be a positive 8 over 4, which is 2. So the x value of my vertex is 2. To find the y value, I'm just going to take that 2 and plug it into the equation. So everywhere I see x, instead of putting x, I'm going to put a 2. And then I'm just going to either go to Desmos or my calculator and figure out what this comes out to, and it will be negative 3. So that means my vertex is 2, negative 3. So if I put this in vertex form, I'm going to take the a value from the original equation. So the a value is 2. And then I'm going to say x minus 2, because remember, x is always lie. So my h value is 2. So in my equation, it'll be negative 2 squared minus 3. Now that I have it in vertex form, I can graph it. So I'm going to go to my vertex, which is 2, negative 3. My a value is 2. So instead of going over 1, up 1, I'm going to go over 1, up 2. Instead of going over 2, up 4, I'm going to go over 2, up 8. I'm going to reflect those points to the other side, and I'm going to connect it with a smooth curve. So we've talked about vertex form, we've talked about standard form. Now we're going to talk about intercept form. So if we want to graph y equals 1/2 x minus 1, x minus 5, This is called intercept form because it tells you the intercepts by just looking at it. And remember, x's always lie, so it's the opposite side. So you know your intercepts, or where it crosses the x-axis, is going to be 1, 0, and 5, 0. However, in order to graph this, we are going to convert it to vertex form again. So the first thing you want to do is you're going to multiply out the two binomials, and then you're going to have to multiply it by the a value. And then you're going to be in standard form, and then you're going to do the minus b over 2a. So let's go ahead and do this. So this is the binomial, so I'm going to go ahead and multiply those two together. So you can use the box method or the rainbow method or double distributing, whatever you want to call it. I'll have x times x, which is x squared, x times negative 5, which is negative 5x, negative 1 times x, which is negative 1x, and negative 1 times negative 5, which is a positive 5. Those middle terms will always be like terms, so negative 5x minus 1x is a negative 6x. Now that I have the two binomials multiplied, I still have to multiply it by the 1/2. So I'm going to distribute that 1/2, and I'll get 1/2 x squared minus 3x plus 5 over 2. Now that I'm in standard form, I have to do the minus b over 2a in order to get my vertex. So my h equals minus b over 2a. My b is negative 3, so once again it'll be a negative 3 times 2 times 1/2. Well, two negatives make a positive. 2 times 1/2 is just 1. So this will just become 3 over 1, or just 3. So the x value of my vertex is 3. In order to find the y value, I'm going to take that 3. Everywhere I see x, I'm going to put 3. Now, I can either do that here in standard form, or I can go all the way back to my intercept form. It doesn't matter. I chose this time to do it in standard form. And so I'm going to just evaluate that, and I get y equals negative 2. So now in vertex form, it's going to be, I'm going to take the a value from my original equation, which is 1/2, x minus 3 squared minus 2. Now that I'm in vertex form, I can go ahead and graph this. I'm going to start at positive 3, negative 2. My a value is 1/2, so I'm going to go over 1 up 1/2. Normally I go over 2 up 4, but I'm going to go over 2 up 2. Normally I go over 3 up 9, but I have to multiply the 9 by 1/2, so I'm going to go over 3 up 4 1/2. And I'm just going to estimate that on my graph. I'm going to reflect those points to the other side and draw a nice smooth curve. We should be able to identify some key characteristics of a graph given a graph. So here I'm given a graph, and they say, well, what is the vertex? So you can just read off of your grid. This here is my vertex. Here, let me get a pen. This here is my vertex right here. And so I go over 1, 2, 3, and down 1, 2, 3, 4. So my vertex is going to be 3, negative 4. My vertex is the lowest point on the graph, so it'll be a minimum. And it's concave up. My roots, or my x-intercepts, are where does it cross the x-axis. So if I take a look at this, it crosses the x-axis here and here. So I'm just going to read that off my graph, and it's going to be 1, 0 or 5, 0. The y-intercept is where it crosses the y-axis. So it crosses right here. I'm just going to read that off my graph. But now my x will be 0, so it'll be 0, 5. I know my vertex. I can figure out my a value from the graph. So if I go back to my vertex, I'm going to go over 1, up 1. So that means my a value is 1. So my equation will just be y equals x minus 3 squared minus 4. All right. Put the video on pause and see if you can do this one yourself, and then start the video and see if you were correct. All right, so the vertex is negative 4, 9. It's now a maximum because it is the highest point of your graph, which means this is concave down. It crosses the x-axis at negative 1, 0 and at negative 7, 0. And it crosses the y-axis at 0, negative 7. In order to figure out what the A value is, I'm going to go over 1, down 1, so that means my A value is negative. This needs to have a negative sign in front of it. So the equation in vertex form will be negative x plus 4 squared plus 9. And now we're going to get into some new terminology. So axis of symmetry is an imaginary vertical line that cuts the parabola in half. And if I ask you for the equation of the axis of symmetry, it'll always be x equals, and the number will be whatever is the x value of your vertex. So in this one here, if we look at the equation here is x minus 3 squared minus 4, we know the vertex is 3, 4, so therefore we know the axis of symmetry has to be x equals 3. And that's just going to be that imaginary line that kind of cuts that parabola right in half. The next thing we're going to talk about is increasing and decreasing intervals. So if I'm given a graph, I always think of this like if you're getting on a roller coaster and you read a graph from left to right just like you read normally. So if I was getting on a roller coaster, if I was getting on here, does my roller coaster first go up or does it go down? Right? So this would be going down. So therefore my decreasing interval is to the left of my vertex. Well, my vertex is 3, well, my axis of symmetry is 3, which is actually all I really need to know. I only need to know the x value. So my axis of symmetry is x equals 3. So that means I'm going to be decreasing on the left side. So I'm going to be decreasing everywhere where the values are less than 3. But if I continue on my roller coaster, now that I'm at this point, I'm now going to be increasing. So my increasing is going to be to the right of 3, or values where x is greater than 3. So let's go ahead and try this one. So once again, you're going to read the graph from left to right. So if I'm getting on my roller coaster, I'm going to be getting on the left side. My axis of symmetry is that vertical line that cuts the parabola in half. So it's going to be x equals negative 2. If I'm getting on my roller coaster here, I'm first going to be increasing and then decreasing. So I'm decreasing where it's greater than negative 2. And I'm going to be increasing where it's less than negative 2. And if we put it all together and do all of the characteristics, so I could ask you for the vertex. So looking at this graph, the vertex will be 1, negative 4. The axis of symmetry is always x equals whatever the x value of the vertex is, so it'll be x equals 1. It's a minimum because it's the lowest point of my graph, which means this is concave up. The roots, or where it crosses the x-axis, would be at negative 1, 0, and 3, 0. The y-intercept, or where it crosses the y-axis, would be 0, negative 3. If I'm getting on my roller coaster here, I'm going to be decreasing here, but increasing here. So I'm increasing to the right of my vertex, or greater than. So greater than 1, and means I'm decreasing when it's less than 1. If you have any questions on any of that, please let me know.